Welcome to this video. Today we want to discuss about the problem number 2 in our internal assessment. So the problem says that the power radiation from a moving charge as this. This is the power expression of a moving charge particle. Actually, this is the expression of the accelerated moving charge particle. Accelerated moving charge particle. This is the expression I like that. The notation has the usual meaning. They determine the angular distribution of this power. Determine of the angular distribution of the power. Find the expression for angular power distribution for the rest particle, rest charge particle, and moving with speed. This moving with uniform speed like that. So the question says that find the expression of the power distribution. We need to find out the angular distribution, and then we need to find out the angular distribution of power for these two cases and draw the angular power distribution for the above two cases A and B, right? So the we take the retardant time with velocity u. U is nothing but, since beta is u by c, so u is nothing but the beta c. Okay, so this is u is nothing but the multiply c with this beta, and it's so u dot, if we cross the u cross u dot, you get this type of expression, and dp by d, this is the p, this is dp by d, solid angle, d omega is the solid angle, this is the s r square, and the corresponding expression becomes to like that. And if you calculate this term, these two expression, and finally you got the expression in like that. If we let the z axis as the along the v, the velocity if along the z axis, then the expression of this dp by d omega is turns into like that. Okay, so in case of the changes the value of beta, the expression will be changes, and there is a theta max. The plot is like that of this power distribution with the angles. This is solid angle is like that dumbbell shape, and this is the maximum theta for which the power density is maximum. This is a polar diagram, right? So for maximum theta, this will be must be derivative will be 0. So dd theta of this power distribution at the maximum theta must be 0, and if you derivative with respect to theta and equal to 0, you get this type of expression, the theta max, maximum theta for which the power distribution along this will be must be maximum. Okay, so in these two case, you if you put the theta max is like that, theta max is the expression like that, cos inverse, within bracket -1 plus minus -1 plus minus root over 1 minus 1 plus 15 beta square, 1 plus 15 beta square by 3 beta, right? 3 beta. And if you put the value of beta is nearly to 0, and nearly to 0, this expression will be theta is nearly to 0, beta is 0, then u is 0. However, for large document, so if beta, if you put the value of beta is 0, that is you need to calculate this expression 1 by beta. So this is the very small, tends to 0 means this is the very small, so we need to express like that. This is 1 uh, plus 15 by 2 beta square like that, and by 3 beta. Okay, so using this formula you get nearly to, this is must be plus minus 1 like that, right? So this theta max is tends to pi by 2 plus minus pi by 2 like that. So the power distribution is maximum along pi by 2 angle. This is the pi by 2, and in the minus pi by 2 at these two angle power distribution is maximum, and the corresponding power distribution beta is 0. So sine square theta term, and the nature will be like sine square theta. And the second one is beta is 0.99, and if you put the value theta 0.99 in this expression, you get the theta max tends to 0. Theta max tends to 0. So that's why theta max is tends to 0, and the expression is the cos square term will be prominent. That's why the nature of this expression is like that. So of this question, you need to find out the power distribution and then corresponding power distribution to special case beta is 0, and next one is the beta is 0.99. Okay, thank you for listening. This is all about me. This is my contact details. Thank you.